Okay, we're going to look at convergence with the geometric series. I'm good. I want to start on this formula sheet that you get. Most of these formulas are actually in the on the formula sheet, but I put this as part of the notes. You've got two main different types of sequences that we have to deal with. Arithmetic sequences, geometric, and quadratic down here at the bottom. You need to know about sigma notation. You need to know that arithmetic progressions have a common difference. They're going up or down by the same amount, but the geometric progressions are getting multiplied. The different terms are getting multiplied by a different by a term called a common ratio. They're getting multiplied by a common ratio. Now, when you say the series, it means you're adding together the different terms in the sequence. In a geometric sequence, if you have a geometric sequence was getting multiplied by 2, say you had 5 and then 10 and then 20, and you're getting multiplied by 2. Well, if you added those, it's pretty easy to see, I think, that series is just going to, if you went to infinity, would just become some infinitely big number. But this little box up here in the corner here, it's called, you're looking at the conditions for convergence right there. And it is that the thing you're multiplying by is between 1 and -1, less than 1, but greater than -1. So any fraction, but zeros, not too interesting, but any fraction between 1 and -1, and when you add up all the terms of the series, it'll get closer and closer to one number. Now, sometimes they like to give questions like this. They'll say, for what values of x does the following geometric series converge? And that's the first question. And the second question is, find the sum of the series of x equals 1. Well, first, let's see for what values of x that it'll converge. Well, you look at this term, there's the next term, there's the next term. We want to take a look and try and figure out what's getting multiplied. Well, the x is turning into x squared, and then, this should be x cubed there. That should be x cubed. Then it's turning into x cubed, and down here it's going 2, and then 4, and then 8. So what's happening is it's getting multiplied. The common ratio must be x over 2. You could divide two terms like this and do the algebra and figure out that it's x plus 2, but it's just easy to see r is x plus 2. And then all you have to do is in this little formula for the sum of an infinite series, the condition is r is less than 1 or greater than -1. So instead of r, you put x over 2. You multiply everything in the inequality by 2, and you get the values of x for which this series will converge. X is less than 2 or greater than -2. Now, if x equals 1, all you do is put a 1 in for x. So r must be a half. And then you could put 1 minus a half down at the bottom. The first term is 3 times 1 over 2 is just 3 over 2. Put that in your calculator. 3 halves divided by a half, though, is going to equal 3. And that's the sum to infinity. So converge means when you keep adding up the terms, they become infinitely close to just one number. For this series, if the common ratio is a half, they become infinitely close. They converge on 3. So that's the story. Okay.